maybe you've heard that area before. Okay, and well, and we're providing in the toxicology testing some of the biggest labs in the world, but we are fairly new to the genetic testing, which is the main thing we're going to be talking today. The meeting is being recorded. So Fernando invited me to talk here with Deborah to talk about how has been our experience when deploying this RT-LAM lab net throughout the country. Not as much as from a scientific perspective, but rather like the real complications perspective we've been dealing with. And I think that may be interesting for you all, because if I understand correctly, you all know very good the scientific part, but when you start deploying these technologies, and you start having different problems, unexpected problems, which is, I think, the most complex part for us during the last 18 months we've been dealing with the pandemic. So in March, the COVID was just starting in the world, and in Chile we had our first case, and we were working we were developing kit for NGS, next generation sequencing, and that's where we were when the pandemic hit us. We thought that we understood that in Chile, at least, no manufacturing capacity was in place at the moment. Nobody was producing any kind of RT-qPCR, RT-LAM, or any kind of technique that could be used for testing. Everything was imported. So we decided, why don't we start doing something here? We may have an issue with the stock of the testing reagents or something like that. Actually, 2 months later or a month later, we started having issues with some of the reagents that were being used by the health agency, the Chilean health agency, the MinSal. I think somebody's saying something in the chat in the opening. Okay. So we decided to focus here. We redirected a lot of energy of the whole company. Like 80% of the company started focusing in setting up, in deploying something that could help for the pandemic, and we focus in the trending technology, which was RT-qPCR, but also in something that we envision at the moment that could be deployed faster and in a more distributed way compared to RT-qPCR, which was RT-LAM. Chile, as you probably know, we're not a developed country, so we don't have many of the capacities of the technological level that are in other first world markets or first world countries like US, UK, Europe, and all of those countries. So we're faced with different realities, and we thought RT-LAM will give us something that could change or maybe speed up the way that we could start testing people faster. So the tech, RT-LAM, you probably already know that. It's retrotranscriptive reaction followed by a isothermal PCR. It's not a new technology. It's been around for more than 20 years, but in Chile, at a governmental level, nobody knew it. The business model was to deploy low complexity on-site labs throughout the country with the aim to increase the testing capacity. And the key partner to doing it was the implementators, which were these small labs deployed in different places in the country that could and they will be the real labs. We will be providing them the technology, the reagents, the all helping them in all what was needed, but they will be the ones doing the testing. And we call it RESIST, RNA Easy Screen On-Site Test. At that time, we were dealing with the test rápidos, which were antibody tests that people start using at the beginning of the pandemic. We knew that they were not working, but that's cool. Like now we've been more than a year in the pandemic, so there's a lot of knowledge that everybody know now, but at that moment it was amazing the level of asymmetric information that there was that you had compared from a scientific from the academia compared to the government, and we were dealing with that, trying to start using things that were very known in the academia but were completely unknown in the government. For example, like doing antibody testing in the citizens. So, what is this? The kit we developed? Well, we first decided that saliva is going to be the matrix, the sample, not the nasopharyngeal or oropharyngeal matrices, because we knew at the time that it was better, was more homogenized sample compared to the nasopharyngeal. Also, the testing was easier. You could do some auto sampling compared to one of the problems that what we were having at that time, which was I think called the septum, which is used for the nasopharyngeal testing. We didn't need that. Didn't need those. Easier, safe, and massive. Massive was one of the more relevant things at that time, and I think it's still fast detection. Well, PCR could take 3 hours, but in reality, the logistic of taking the sample to the complex lab testing and giving the result, at least during last year in Chile, was around 3 days in average, compared to an on-site test where, like, if you could do a PCR or a RT-LAM on site, the difference wouldn't be that much. Will be 1 hour more or less, or maybe 2 hours more. But the most relevant thing was to have the lab on site compared to a centralized system, which was still the system that the MinSal, the Chilean Health Agency, still use. Sensibility. We did this evaluation, and we also, there's a lot of reference already on how they are compared to RT-PCR, which is still the golden standard. And in reality, in Chile, all the tests that are being done by the government, probably 95% is still RT-PCR. But compared to the RT-LAM, we proved. But wasn't easy because we didn't have the Chilean government didn't have the system in place to test Chilean manufacturers. They only keep the window open to importing tests and registering these external manufacturers, but they didn't have for Chilean manufacturer, which was one of the problems we faced at that time. Also, plug-in labs. We wanted to have this option of low complexity lab. The price, the cost of setting up a RESIST lab is like 5 to 10 times cheaper than to set up a RT-PCR equipment. Now those differences are changing, but during the last year, when there was no equipment in the country, and to import a real-time PCR took a couple of months. Speed was critical, and you already know, but RT-LAM could be done just in a hidden place, so of course was much easier to set up. And the low cost. And also, if you want to be massive, you need to be cheap, and that was one of the focus. We wanted to be competitive to those alternative imported alternatives. So we set up this lab, this net. This took a lot. I'm just summarizing a lot of work, but we were able to. Now we have 8 implementadores, which are these partners we developed throughout the country. These partners came from different realities. Some of them were genetic labs, but others were like entrepreneurs who were unemployed and wanted to make something during the pandemic. So we help them, we teach them, we give them all, like we help them hire. We told them what was the experience, the people they should hire. Sometimes we send them actually the profile of the people they should hire, because again, they didn't have any kind of experience, just the will of doing something. So we developed these eight companies. Now we have 28 testing labs throughout the country. We are testing through those labs more than 160 organizations. Like some of them are big companies, medium, small companies. Some of them are nursing home. There are some schools. There's a lot of different organizations that have been testing with the Resist. We're testing more than 22,000 people every week. We're very proud of that. We've reached 30,000 sometimes. And also the beauty of this is that while the unemployment was like really going very high for the country, we were giving and hiring people to this. Through this testing net, we have 42 analysts, but also if you consider all these 8 implementators, it's more than 60 or 70 people who is working with the Resist in the country. So at least that makes me very proud. Well, when we were setting up these labs, this was our expectation of what we will be facing. Before the COVID, we were just selling to other countries, never in Chile. Our main market was in the US, so that was our experience. This was like our expectation, but in reality, this is what we faced when we were deploying the net. And like really like adaptation was the word, and teaching and improving and continuously improving what the implementators had to begin with. It's not that this is still the lab site they are using, but this is how they started. So imagine what we had to do to, I don't know, to improve this house in the left corner. So the challenges we faced were we really need to be very fast in the go-to-market strategy, because people need it. We were testing a couple of thousand people a day, and at that time, and I still believe that the only way to control the pandemic was by TTA, and you cannot do that if you're not testing a firm percentage of your population. Some studies say 2, 4, 6% of the population every day. I think, well, now I'm convinced that we're not going to reach that, because no country aimed for that. So we're faced in the reality of the quarantines, which is still a very difficult reality we are facing in the country. Like when a city goes out of control, we're quarantined. We call it phase 1, which is everything closed. We're still suffering for that, but I was convinced, and I'm still convinced, that if we could have raised the testing capacity of the country to 300, 600,000 people every day, that could have been avoided. So go-to-market speed, early adopters, government and regulation were not prepared for a new technology or a different technology compared with the qPCR. Business model was how to implement this to test as much people as possible. That's why we decided to do pool testing. At that time, nobody was doing. Like now it's trending, but at that time, nobody was doing. The same with saliva. We started with a resist color. You already know that these pH change make a different color, so you can see that. But the reality is you have more error percentage when you're using that, because sometimes the sample are not that perfect. So we improved that. We updated to a resist fluor, which uses the plurimetric measure of the change. So we are not, we improved a lot the percentage. I really don't have that data in my mind now. It's been a couple of months since we made the change. So maybe you have question about that. We can talk it not during this presentation, but later by email. Know-how transfer, as I showed you before, these implementadores, only some of them has the previous experience, so technology transfer was a challenge. Quality assurance, contaminations and problems due to low laboratory standards and I could say are still a continuous issue, but we need to fly to different places like next day to solve this, because when something failed, it was something that always happens when you're providing somebody, you're the first. They suspect of the kit and then of everything else, and also hiring people very fast. We hired a group of, I think, 14 people in a month. So hiring the people, creating a group that could work together with the speed, with the roles was also complex. But after doing all that, and like the numbers I was showing you, the kind of impact we had, and what made us happy. For example, we made this Cura Mobile, which it's still the lab we use to test ourselves, but also we were able to take this mobile lab to different places where it was needed in the region we live, and sometimes to other regions to help. We were able to open some schools. This is my daughter's school, which is open since we opened it in October, and the core reason they opened was because they were convinced that by testing symptomatically, screening continuously, they will be able to find out these potential positive people very fast and isolated. So I'm very happy because I have four daughters, but 3 of them goes to this school. So that's something that made us happy. And we are also, I think we have 4 schools now, not more because there's some of a political issue with the schools in the country. When the politics get into the science, that's what happened. We are also testing the firemen, the police in the city, helping them to be safer. Small business were able to open. So it's not just for the big companies, but also small businesses are able to open and feel and work in a more safe environment. And we sometimes just laugh about these are the testing tubes we use in Cura. We test ourselves 2 times every week, and when the rate of the positive rate goes up in the city, we sometimes increase it to 3, and when it goes low, we reduce it to 1. But no, actually, we haven't reduced it to 1 test per week in a long time. But that's how we start. More highlights. This is Javier Gimpel. He's the person in charge, the scientific in charge of deploying the resist. He could have been talking today actually, but he didn't want to. He don't like to talk so much. He was chosen the Premio Científico Innovador 2020 because of the resist. We've been able to help in towns and small towns where they are having a problem in isolating the people, which has the virus. We've been able to help. We also help some of the elections we had last year. Nursing, as I was telling you, we've been helping the Bar de Cristo, which is a very big net of nursing homes throughout the country. And how we see the future, the bright future, well, now we have a solid application specialist team, expert in on-site testing. We want to leverage that. We also have this red implementadores, implementator net, with 28 on-site labs throughout the country. We want to use that to test other things that are not just COVID. Hopefully, if COVID start going away, that will be that's the idea. And also, we've been able to gather experience not only from the theoretic point of view, but also from the user point of view, which sometimes you don't understand if you are not really involved with the final customer, which is, for example, the simplicity of the system, how the manual, the instructions you give them, that kind of experience that we've been forced to learn very fast. It's also one of the things that we want to use for the future development. This is the amount of people we test so far, and still growing every day. And this is one of the mobile labs that is now being deployed in different places. You can see the difference from how we started with these really low quality houses, and now the kind of on-site lab that we are putting in different places. This one is being deployed by Greenvolution, one of our implementators. And that's it. I hope you like the presentation. I'm going to start sharing my screen now.
All right. Thank you so much, Manuel, for that really inspiring talk. And I think it's really impactful to see that with consistent testing, a lot of things are able to open up and people are able to approach towards normal life. So the floor is open for anyone who has questions for Manuel, comments, or conversation points. You're free to unmute yourself and let's hear you.
Seems like no questions.
Hey, Manuel, I'll break the ice. Nice talk. And I was wondering because about the regulations. So two things. How do you handle the permissions from the Institute of Public Health? To what extent are you allowed to say like a patient is or a sample is positive or negative? How do you handle the information? So one, the regulations from the public health, and two, how do you handle the information with patients and customers?
Okay, yes. So that's one of the things that have been changing through the pandemic. When we started, well, how we define the testing we are doing, it's for asymptomatic people. So if you have any kind of symptom, you should go to test yourself in an RT-qPCR in a diagnostic laboratory. This is just for screening non-symptomatic people. So it's like a screening outside of that. So if you say no or yes, you're positive or negative, or you're reactive or not reactive to COVID. If you say no and it's a false negative, it's not like you are putting somebody who should have been tested under the right laboratory regulations. It's like that was the approach with which we started at the beginning, which is if we don't test this person, that person is going to still be. I don't have the English word in my mind, pero no sería contagiando a otros. So that's how we started, but asymptomatic. Then things like start changing a little. We were forced to deal with the local health agencies, the Ceremis de Salud. In Chile, we have like a regionalistic way of implementing the health. So some regions, the Ceremis, which is the local agency, were open to keep the screening. Some of them were not because they were having different issues. For example, in the north, the mining companies, they were testing with PCR. They have a lot of money, so they just purchased these huge labs. So there we have more issues because the Ceremis there were dealing with the mining, and they were trying to get that data into their system. So they were more regulated and more rigid. But in the rest of the country, once they understand the extra support they can have from this net, they started helping us. And well, I think around 6 months ago, we were able to finally validate the resist with the ISP, the Health Institute in Chile. So now if a diagnostic lab wants to use it, they can use it. There's some issues with the saliva still in Chile that is not accepted as a source of samples, even if it has been validated in many places in the world. But so that's something that make the resist when applied by implementators is still an issue. But we choose not to be a diagnostic kit because of that, to stay away of those kind of regulations, but still make a difference. I think that was the first question. The second question, can you repeat it, please? You're still mute.
Okay. Yes, the second question, how do you handle the information with the patients?
Okay. Yeah, this is like a more, this is part of, also it's a gray area. I think there are already a regulation on how to use this information from the company, but this is not, this is how the companies deal with personal data of their employees. There are already regulations about that. So we just copy those, or there's some variation throughout the different implementators, but it mostly, the test has just a number. Only the person who knows the number will know which was, if somebody was positive or negative. And usually just the human resources director knows that data. So, and that's the person who usually deal with that level of confidentiality. And in some places, some companies have set up a specific area to deal with the COVID. So they sometimes change who manage the health information when they haven't done that before. But there's not just one way. Some of the implementators also develop an application that send the data just for the positive, and he can choose to, or we don't say positive, we say reactive or non-reactive, also because of the regulation. But there are different ways of doing that, but mostly we manage the confidentiality so that we don't do it ourselves, but our implementators, they do it in a way that only the person who is reactive and somebody within the company will know that, nobody else. And they are not positive because we're not a diagnostic kit. So even if they get reactive, we tell them, now you have to go and test yourself in a regulated lab.
All right. Thanks, Manuel. Any more questions? Anyone?
I have one. I mean, I know Manuel, and we have talked a lot. But anyway, I would like to ask. Let's say you have your own reactions, and suddenly you find, I don't know, in the literature or in the Reclone network, that there is an amazing BST large fragment working really well for lamp reaction that is the best that humanity has ever seen. What are the challenges if you say, oh, I really want that enzyme to be part of our kit because it's open source and you can use it? What are the challenges or steps from that point? Because I understand there is much more than just the technicalities of how well the enzyme is working and make you decide to implement it or not. If you can comment what you can a little bit about that.
Well, yes, when you're taking an enzyme, well, let's see how I can say this. I cannot say everything how we do it, but in some cases we use our own enzymes, our own reagents. In some cases we purchase from outside, depending on how the speed and the level of development we have in that particular application. But for the enzymes we already have on the market, I think stability is usually one of the issues. Quality controls, when you are using something that is related to RNA with DNA, RNases are always complex to get rid of. So the purification process is something. Then also when you have to sell it, you have to be you need to have some profit from it. So the yield of the process is relevant. The stability, the long-term stability, when you are sending this away to different logistics, sometimes you can have the perfect standard in your own lab, but once it leaves your lab, you need to be able to anticipate that. So I think the formulation, the stability, and the quality control are the most critical part. You can choose how you define the quality related to the applications of the product, but also that will narrow how it's used. You can say only for DNA, yeah, you can do it, but you will not be able to use it with this virus. I think that's the more complex thing we've been forced to consider. And I think I mentioned that when an external person is using an external customer, sometimes you write anything, like everything in a manual, very, very clear, but they just don't read it. They don't. So you need to go there, teach them, and that's another level of knowledge that the scientific we don't usually have. You would anticipate that, but sometimes that's why the kits don't work. Not because of the components, but how it's implemented in the lab.
Pretty cool. Thanks, Manuel. Thanks, Fernand. Any more questions? Anyone? I actually thought like the what you just said right now about actual hands-on training is really key. It's really important to help people make the most of whatever kit is developed. So that's really something cool. Yeah. So the floor is open for more questions. If I don't hear any more questions, I have some announcements to make. It's going. Daniel, are you putting your hands up?
No, it's just a comment that thumbs up. No more questions from my side.
Okay. And Fernand, I thought you wanted to ask a question. And I don't know if Adrian is raising his hand up, but Fernand, go for it.
I think Adrian was going to say something.
Okay.
Oh no, sorry, that was a thumbs up. for the presentation. Thank you, Manuel. That's a fantastic job you're doing there. And you managed to kind of find your way around the system to do just the reactivity and not necessarily go, you know, head to head with the whole establishment there. So that's the management achievement that I think it's hard to achieve. So congratulations.
Thank you, Adrian. Yes, something we said during the last year, like let's stay in the gray zones, so like nobody can forbid what we're doing, and we can keep going. So yes, it was not that easy, but we're happy.
Cool. Fernand?
Yes, a general question, because in this network we are working towards the development of open resources, open protocols. What do you think, if you could comment, what could be the role that these open technologies, open resources could play in a company like Kurabiotech? Where do you think, or where we should go? What is your advice? Where we should go in terms of making an impact in companies like Kurabiotech, in terms of open technologies, open protocols?
It's not easy to think about that, but I think like we're a small company still. I think for any company that is thinking of going into something new, we all do the same. We start reading, researching, and we start from the basics, and then from that part up. So we all go to the open sources to learn, to, like, we call it like to domesticate the enzymes first, put all the process, understand how it works, check protocol, check everything. So even if you're a company or if you're an academic lab, you still need the same, you still have the same need of information. And also when you've been, maybe this is a different point of view from what you were thinking, but something, if somebody has been working with an open source enzyme and has been dealing with all these problems, they can actually then move to a private company and have an alternative employee there, because the companies also need that information, and you can choose whether to develop yourself or hire somebody who has been working on that. Also collaborations, for example, I don't have something very clear, but we decided to give a 10% of the tests we will deploy for free. Every 10 tests we sell, one will be free for this nursing home. Sometimes companies have this also this non, and maybe philanthropic forces inside them, or projects inside them that can be also be used to collaborate with external groups, like, for example, something that is open. But I think that important, when you're selling something, you know, you have to, you are responsible for the whole product. When you're giving away something, it's different. So why I'm thinking that is, if you're going to give something away for free, the level of compromise you have, it's different. I think that's something that I don't know how to say, but when you're open, maybe it's a trade-off. It's okay, you can use this for free, but it's up to you to deal with the implementation. When you're selling the process, you have to deal with the whole chain of complexities. Maybe it's not an answer, but it's like a comment back on when, like, the level of responsibility when you are doing something open, I think moves to the person who is using it, compared to when you are selling. I think I don't give you a straight clear answer because I'm thinking about it while I'm saying them, but I think when we talk about this last time, like, at least in Chile, we need people who learn about these things, and we are not a developed country, so a way to learn the experience and to confront future pandemics or needs, it's open. The problem when you're private is that you need to be careful with the confidentiality, with the patents, with that. When you're open, you're free. It's like the old science, and that's moved very at a different speed. Yes, you have the patents to learn from, but you need to wait for the patents to be open, to be available, and that takes a couple of years. So it moves slower. I think the pandemic has showed that we all learn from the same sources during the last 18 months. That's a different. Sorry for my lack of clarity.
I think it's really cool, and I'm going to jump in right now because you guys have basically laid a good foundation for my announcement. I think a number of things that came up is that to find Manuel has learned to find his way around the system to be able to make impactful science, and also learning about the complexities between science that is sold versus science that is given away as a charity. So that lays the foundation of what I'm going to say, because we are planning for the next Reclone Symposium, and the theme for that is advocacy for diagnostics and I should say it properly, advocacy for innovation in diagnostics in LMICs, low and middle income companies. So this is a good plugin to come and learn, and also to come and contribute to many people learning about advocacy. And because indeed a lot of scientists are interested in these topics, but they don't really know where to start. So I think it's probably going to be a good way to seed, the flame that would, encourage all of us to begin to take steps towards advocacy. So adding more vague comments to some more comments, and that's just that. So we originally had planned for that to be July 21st, so potentially the next Reclone meeting. But upon consultation, because we've been trying to pull up having some government officials in the Reclone come talk to us, and it looks like we might be able to pull it off. So we've decided to postpone by 1 week to July 28th. So fingers crossed, and please, if you are interested in maybe giving a lightning talk at the symposium, please shoot me an email and let me know, and we will put you on the agenda. So that's that. I'm also going to be sending an email around the email list, and also placing this on the forum. So that's the one Reclone assignment that announcement that we have. Jenny sends her apologies. She is currently sitting on a panel that she cannot escape from. So she honestly would have loved to be here, but she said she is definitely going to watch the video of today's talk. So that's that. Then one other small announcement with mixed feelings is that this is going to be my last Reclone meeting as the coordinator of the Reclone Forum, because I am moving away to a new adventure. So I'm actually going to be leaving the University of Cambridge for another position in publishing. So I'm still going to do my best to keep in touch, but I would not be too much in your face as I always am. So it's been wonderful getting to know a lot of us, and also connecting, listening to great talks, and just knowing you guys do your science. So this is me saying thanks for having me, and also goodbye in a way until I see you guys again. All right. So thank you, Manuel. Thank you everyone for coming today. And this talk is going to be edited and uploaded to the YouTube channel. So if anyone wants to have a recap, please feel free to have that. And yeah, see you all.
Thank you, Deborah.
Well, thanks, Manuel.
Ciao, bye bye, everyone.
Thank and good luck.
Thank you.
You.
Thank you.
Thank you. Thanks, Man. Thanks, Daniel.
Take care.
Yeah. Thanks, Adrian.
Bye-bye and good luck.
Thank you.
Bye. Good luck.
Bye. Thank you so much.